Good afternoon, all of you. I welcome all the students to Pune College of Arts, Science and Commerce, Camp Pune 1. I teach statistics, paper 1, discrete probability distributions and time series. In last lecture, we have started the topic truncated Poisson distribution. I had given you PMF of truncated Poisson distribution, which is truncated at x equal to 0. The PMF of truncated Poisson with x equal to 0 value discarded is nothing but e raised to minus m, m raised to x, total divided by factorial x, multiply bracket 1 minus e raised to minus m. X taking value from 1, 2, 3 up to infinity. M is any positive constant. I also told you the parameter M can be written sometime lambda. We proved this function is a PMF by taking total of Px over the range x equal to 1 to infinity. After this, we derived mean of truncated Poisson distribution, and the answer was small m divide bracket 1 minus e raised to minus m. Today we'll try to proceed how to develop variance of truncated Poisson distribution. Variance of truncated Poisson distribution, as usual, variance xt, t for truncation, is expected value of x square t minus square of expectation. That means to calculate variance, we need two calculations. Out of these two, we already developed expected value of xt, that is a mean of truncated. Answer is m divide 1 minus e raised to minus m. Now let us see how to get expected value of x square t. This equal to expected value curly bracket xt multiply xt minus 1 plus xt. If you simplify curly bracket, you get same quantity as x square t. I took expectation inside curly bracket, so you get two expectations. I label this as 1 plus this as 2. Answer of expected value of xt is already with you, that is m divide e raised to minus m. We try to get first expression. Expected value of xt bracket xt minus 1. Usual way, expectation replaced by summation over the range. What is the function inside expectation? Put as it is. Multiply corresponding probability function. This is the formula for truncated Poisson at point 0. 1 minus e raised to minus m constant. E raised to minus m is constant. Take it out. Now if you look in this step, x begin from 1. But in the next line, I write x start from 2, because if I put x equal to 1 here, this bracket becomes 0. 0 multiply anything is 0. So it is not necessary to begin from 1. You can start from 2. Because at 1, this whole quantity is 0. So I start from 2. M raised to x divided by x minus 2 factorial, because x factorial written as x into x minus 1 into x minus 2 factorial. This product cancel with numerator. So you get such type of thing. I can apply exponential series at this place, but you can see the change. Here it was m to the power x. Here I wrote m to the power x minus 2. This minus 2 adjusted with m raised to 2 outside. So this multiply this gives answer m raised to x. This is very important step as the adjustment to go ahead. If power is denominator as a factorial, you can apply directly exponential series and answer is e raised to plus m. Remember nicely. I repeat again. In infinite series, power of constant should be factorial in the denominator. If it is true, the answer of this infinite series e raised to constant. Now e raised to plus m cancel with e raised to minus m. So you get expression 1 m square divide 1 minus e raised to minus m. So I got answer for first expression. Second expression is already with you, m divided by 1 minus e raised to minus m. Therefore, expected value x square t is 1 plus 2. The 1 is m square divided 1 minus e raised to minus m plus m divided 1 minus e raised to minus m. Denominator is same, common LCM, numerator will be added. Now we proceed ahead. Hence, variance of xt is expected value of x square t minus square of expectation. Put the expressions, you will get m square 1 minus e raised to minus m whole squared. LCM is 1 minus e raised to minus m squared. This quantity will be multiplied with this as it is. Get a simplification. So you get variance of xt m divide 1 minus e raised to minus m whole squared in bracket 1 minus m plus 1 e raised to minus m. This is a simplified expression for variance of truncated Poisson distribution at x equal to 0. Now we have remark that relation between variance and mean as compared to untruncated distribution. It can be easily observed that variance of truncated is less than variance of untruncated, which is also true in case of truncated binomial distribution. For large value of lambda, you can put a lambda, you can put m, it doesn't make any difference. So if lambda is large, that is parameter m is large, then expected value of truncated is expected value of untruncated, and that comes to be lambda. Variance of truncated same as variance of x if lambda is very, very large. So if you look actual value, variance is smaller than original variance, whereas truncated mean is bigger than original mean. That is a theoretical part you have to prepare nicely for making a derivation of truncated mean, truncated Poisson, either in binomial distribution or Poisson distribution. We proceed for some numerical examples, and then if time permit, we'll open the next chapter. Suppose x follows Poisson with lambda equal to truncated below at x equal to 0, then these are the several bits under the same heading. Calculate probability xt equal to xt greater than equal to 3, probability xt less than equal to 4. These are several events. Calculate expectation of xt Under this parameter, variance of xt, and verify the relation between truncated mean and untruncated mean. Let us proceed ahead. It is given that xt follows Poisson with lambda 2. So this is the function of truncated Poisson at x equal to 0. 0 is not observable, not available, so it will be not considered in the calculation. I put lambda equals 2 and simplify. We want to find by using this function different probability. Number 1, probability xt equals 2. Very simple example, provided you remember this formula. So you have to remember PMF perfectly, then you can solve such question. Just replace x as 2 and get the answer by scientific calculator. I want probability truncated random variable gets greater than equal to 3 equals 1 minus probability xt less than 3. I want to tell you one thing here. When I go through your assignments, many students write small x under expectation as well as under probability x should be capital equals some particular value, you can write small x. In my paper, capital X is a random variable taking many values. Small x is a fixed value, only one particular value taken by your random variable. So be careful. If you are writing a random variable, it should be capital X. And if you evaluating under summation, it may be small x. Probability xt less than 3 equal 1 minus probability xt1 plus probability xt2. There are 1 or 2 students, in case of binomial, they put 0 also. So 0 is not observable. So xt less than 3 will not include 0, it will start from 1. Put the value and simplify, you get answer. Xt less than equal to 4. So addition of 4 probabilities by putting in place of x1, x2, x3 and x4. You can simplify this. Final answer will be 0.9387. Now you have truncated mean. Formula is lambda divide 1 minus e raised to minus lambda. Replace the parameter lambda as 2. This is the answer of your truncated mean. Variance truncated for Poisson given by this formula. Replace lambda equal to 2. Get simplification. Finally, you get variance of truncated 1.3742. From your first year knowledge, I taught Poisson distribution with range 0 to infinity. And we know in case of Poisson distribution, mean and variance both are equal and they are equal to parameter lambda. So expected value of x is a lambda equal to 2. Expected value of truncated mean 2.3132. Easily you can see truncated mean is greater than untruncated. This is the theoretical result verified by numerical problem. Variance of x is lambda. Variance of x is 1.37. What you got here? You can see variance truncated is smaller than untruncated. So this theoretical result verified with the help of this numerical example. Now we go one more example, which is a theoretical. In a certain industry, number of replacement of certain component during a month follows Poisson distribution with parameter 3. Past experience shows that the random variable takes value 2 and above. Before proceeding ahead, let us try to understand the problem, what it says. In a certain industry, number of replacement of certain component during a month. This is your variable under study. Question says number of replacement follows Poisson distribution with average rate 3 over the month. In addition to this, the past record says minimum number of replacement is 2 or more than 2. That means in this example, from original Poisson, value 0, 1 is not observable. So this is the problem of Poisson where two values are truncated. They are 0 and 1. See the bit number 1, what it says. State PMF of truncated random variable. Bit number 2, find probability that number of replacement is in a particular month is 5 and above. Third bit, find the probability that number of replacements will not exceed 3. We will see one by one. Let us start with random variable capital X. Number of replacement of a component in a month as per your question. It is given that X takes values 2 and above. In other words, X is truncated below at 1 because values observed from 2 onward. So 0 is not observed, 1 is not observed. So it says that truncated random variable below at 1. Therefore, we have xt truncated random variable follows Poisson with parameter lambda equal to 3. How to write PMF? It is by original definition of truncated function. This is a way of getting a truncated function. Px original formula divided by 1 minus probability x belong to truncated value. This is the original Poisson function as a numerator. E raised to minus lambda raised to x by factorial x. Total divide 1 minus curly bracket probability x equal to 0 plus probability x equal to 1. How to get probability x equal to 0? Easily from the numerator. Replace x0, x0. Anything power 0 is 1. 0 factorial is 1. So answer of probability x equal to 0 is e raised to minus lambda. How to get this second probability? Replace x equal to 1 in the numerator, in the denominator. Answer e raised to minus lambda, lambda raised to 1. 1 factorial is 1. So answer is lambda e raised to minus lambda. If I take a minus sign inside, you get 1 minus e raised to minus lambda e raised to minus lambda. This is your truncated distribution of Poisson where two values are truncated, 0 and 1. If it is truncated only at 0, this will start from 1. If it is truncated with 0 and 1, so two probabilities will subtracted from 1. Now we'll play by this function for the rest of the bit. Therefore, probability xt equal to x, e raised to minus 3, 3 raised to x, factorial x, and there should be, everybody make correction in my notes, 1 minus e raised to minus 3 minus 3 times e raised to minus 3 bracket. This quantity should be here. It should be here. That is missing. So take care of this. After writing the function, second bit says find the probability xt greater than equal to 5. If I calculate this directly without complement, I have to add a probability begin from 5 till infinity, which is a infinite calculations. And that's why I use a complement result, 1 minus opposite of this event. Here it is a greater, so I write smaller. Here it is equal, so I will not write equal. Now it has only limited calculations. 1 minus curly bracket, x is 2, x is 3, x is 4, because it is strictly less than 5. So what is the benefit of this complement result? You can reduce your infinite calculations to finite. 1 minus this, you can get the answer by using your function what we wrote here. Next, probability xt less than equal to 3. This equal probability xt equal to probability xt equal to 3. 0 and 1 will not come because it is discarded, it is truncated. So less than equal to 3, according to this example, variable start from 2. So there will be no value below 2. Replace the values in the function and get a simplification. So this is your example which is based on truncated Poisson distribution. Now we'll start a new chapter under the heading of time series. This is a little bit theoretical chapter having some numerical problems. Let me explain today what is the meaning of time series, what are the real life examples of time series, and then we'll proceed ahead. If I want to define a time series, it will go like this: collection of observations on a certain variable in chronological order. This word is most important word in the definition. When you write a definition of time series, this word should be there. Is known as a time series. What do you mean by chronological order? Data which is collected is considered under chronological order if time between any two successive observations is same. then we are taking observations with equal period of time. That collection is a chronological order. So any collection of observations which is collected in a chronological order is known as a time series. In other simple word, if your variable is a time dependent, that collection gives a time series. For example, if I say marks obtained by student, here marks is not a time dependent. So marks obtained by student will not be considered as time series. Any variable which changes according to time, that variable gives a time series. We have many examples in day-to-day life where we can observe a time series. Number one, daily prices of gold. If we visit any jewelry shop, we'll find that prices of gold keeps on changing on a daily basis. So my record prices of gold on daily basis gives a time series. Weekly sales of certain departmental store also provide a time series. Monthly deposit in certain bank also provide a time series. Yearly production of food grains in certain country will provide a time series. Example 5, hourly bacterial count in certain culture at a laboratory, and so on. There are many examples where you can observe time series. You can see now what is the difference in these 5 examples. Example 1, I make a record of variable on the basis of daily. That means between two observations, I put a gap of 1 day. So every observation is away from other by 1 day. That is a concept of chronological. Example 2, I record sales of certain departmental store, that is weekly basis. Suppose I decided to take an observation on end of the week. Let us say weekend as a Sunday. So Saturday evening I will take an observation and I will continue this till next Saturday. So every Saturday evening I will put the record sales of certain departmental store. So between the observations there is a gap of 1 week. Here period is daily, here period is a week, here period is month, here period is yearly. Sometime between the observations period may be hour also. So between two observation, how much gap will be there? It depends on the problem under study. It may be daily, it may be weekly, it may be monthly, sometime yearly, sometime hourly. That means under time series, you are not studying one variable, you are studying two variables. And that is why time series provide bivariate data. You can recall your first year chapter correlation analysis, regression analysis. To study correlation, to study regression, we define two variables. That is a bivariate variables. Now under time series, one variable is time, which is fixed, and another variable which is under your study. So I can define two variables under time series as like. In a time series, we denote the observation on main variable y as y1, y2, dash dash yn continue. What is y1? For example, here price of gold on first day. Y2, price of gold on second day. And continue like this. So you get y1, y2, dash dash yn. Continue like this. Now what are the respective time factor? For y1, we have t1, small. y2, small t2. So if I take first example, y1 is the price of gold, say on Monday. Price of gold on Tuesday. Price of gold on Wednesday, and so on like this. Thus, time series can be represented as a function of time factor, denoted as capital Y equal to Ft. Here, t is an independent variable and y is a dependent variable on t, because we know time changes according to itself. It doesn't have any influence of extra factors. Whereas y variable, which is the price of gold, which is same as departmental store sale, deposit in the bank, and so on, this is a y. So y depend on t. In time series, y considered as dependent variable, spelling is wrong, try to correct. Whereas time t is considered as independent variable. We can denote time series by notational form. Time factor t, you may write capital T, you may write small t. T1, T2, T3, dash dash, Tn, continue like this. Yt, value of variable y at point t. For T1, we record y1. For T2, we record y2, and so on. So this is an introduction for time series.